we're going to figure out how the conventions are for naming compounds. The neat thing is they follow rules. That makes it easy because we have rules that we follow. And if we follow the rules, everything will be great. The bad thing is there's more than one set of rules. And you're like, what? What moron came up with this idea? Well, the thing is people started naming compounds before scientists got together and solidified the rules, and those names stuck. People just got used to them. And once people get used to things, it's hard to change. And so we have more than one set of rules for naming things. But the nice thing is there's one for ionic compounds and one for covalent compounds. So we're going to divide these two up. We're going to go ionic compounds, ionic, and then we're going to do covalent. Ionic and covalent compounds, and then this is going to be for naming. And when we do our naming for our ionic compounds, wait, whoa, what happened there? Okay, that went fast. That's a lot of stuff there. Well, I guess it's a good thing these slides are available online. Okay, so anyway, ionic compounds, this is going to be with a metal and a non-metal, right? So we're going to look at a formula and we're going to say, does it have a metal? Does it not have a metal? Okay, so we're going to say metal with non-metal. Okay, and then our covalent compounds, this is going to be non-metals with, and it could be non-metals or it could be metalloids. So with non-metals, metalloids. Okay, so it's going to be non-metals with non-metals or non-metals with metalloids will be covalent. All right. Now, for naming these, all we got to do is we just got to take the name of the metal. So we just take name of metal, and then we add the name of the nonmetal plus name of nonmetal, name of nonmetal. And so, for example, if we have NaCl, we call this sodium chlorine, right? No. We call this here sodium, and then I'm going to write chlorine here for just a second. Okay, and we change this. We don't call it sodium chlorine, we call it sodium chloride. Okay, yeah, so we change the ending to IDE. So that becomes sodium chloride, okay? And then, so if, for example, I had Mg, let's go, Br2, okay, MgBr2. This becomes magnesium. And then we change the ending here. So this is going to be bromine. And we change it from bromine to bromide. Okay. And that's nice. That's wonderful. I like this rule. I can do this. Now, where it gets a little tricky is when we have our transition elements. Our transition elements, some of them will have more than one valence. That is to say, they could have more than one charge. And we remember that iron, for example, when we were messing with quantum mechanics and orbital notations and all that fancy stuff, iron could be a 2+ and it could be a 3+. And that changes the formula. So if we have Fe, okay, FeCl2, that's one thing, and we could have FeCl3, Cl3, depending on whether or not this iron here is a 2 plus or a 3 plus. Okay? And so if we just call it iron chloride, that's not enough information. It's not enough information. Now, a long time ago, the way that they would do this is they would use Latin, because all smart people know Latin at one time. That was kind of like the thing. And so they called one of these ferrous and the other one ferric. So this would be ferrous chloride and ferric chloride. And maybe you've heard of this. Maybe. They used to teach it this way. They stopped because how many people here studied Latin? Not many. I did. I did. Oh, you did? Woohoo, cool. Okay. That's awesome because now I don't have to go to church to find somebody to talk to. Okay. So that's the way they used to do it. Now, the way they do it now is we still call this iron. So this becomes iron, I-R-O-N, okay? And then this is still chlorine here, okay? And we change it to chloride. Okay? But what we do is we take that charge here and we throw in some Roman numerals. Because remember, the Romans were the people that spoke Latin. And if we're not going to learn Latin, at least we can remember the numerals, right? So this becomes iron Roman numeral 2 chloride. And then this one here becomes iron Roman numeral 3 chloride. Okay? So, when do you use the Roman numerals? Only transition elements. So you would not go sodium Roman numeral 1 chloride, because sodium is not a transition element. Okay, so it has to be a transition element and it has to have more than one charge. Any questions on that? Okay, all right, then. I kind of did this one, didn't I? Yeah, I totally did that one. Okay, well then, what's that on the shirt? Remember your Latin. It's a Ferris wheel. Oh. When we get to covalent compounds are the same in that we add, or we take the names of the two different elements. Okay, so we're going to take the name of cation, so name of cation, and then we take the name of the anion, okay, name of the anion, and we put them together, but we change the ending here to IDE, just like we did before, okay? So it's just like this, no Roman numerals, but we have some Greek prefixes because Latin wasn't enough. So you got to know your Greek prefixes. And these would be good, I guess, to write down. Okay, so you have mono. I'm just going to put them over here, like mono. That's that kissing disease, right? And then you have di, and then tri, and then tetra, and penta, and hexa. And then I always have to double check on 7 here. Hepta, octa, octa, nona, and then deca. Okay. All right. And what we do then is we put these Greek prefixes in front of our words here, okay, to show how many of each of these elements we have. Except sometimes we don't. So for example, if I have, if I have here CO2, this is not monocarbon dioxide. Okay, so this is, I'm going to go mono, crossed out, carbon dioxide. Okay, change the ending to "ide," di because there's two oxygens. So if you only have one element here in the front, only one of them, then we don't put the Greek prefix in front of it. And you've heard of carbon dioxide, right? So we should remember that one. Okay, all right. And then there's also an exception on this, and that is sometimes we have vowels next to vowels, and that gets things confusing. So if we have, say, N2O, like this. Okay, so this becomes dinitrogen monoxide. Okay, now hold on. If you're writing in pen, monoxide, that's too many syllables. And so over time, people have just decided to cross one of those vowels out, and then we pronounce it monoxide, right? We don't say carbon monoxide, right? We say carbon monoxide. We just get rid of that extra vowel. Okay? So those are just kind of the funny rules. Now, it's easy to remember these things because mononucleosis, one nucleus. That's the kissing disease. Di, as in dicycle. When you go to Greece and you want to get a two-wheel transportation device, you go, oh, can I borrow your dicycle? Right? Totally, everybody. Tricycle, tetra, those are those fish with the four fins. This is a building in Virginia. This is what you do when you don't like somebody. And, well, and these I remember because September is the 7th month, October is the 8th month, November is the 9th month, and December is the 10th month, right? It's not? How do we possibly screw that up? This goes back, see, if you studied Latin, you'd know this. So back in the day, there was this republic. And then the republic, they had this person that was elected and just decided they didn't want to leave office anymore and became the dictator. And when you're the dictator, you get to do things like, you know what? I want to name a month after myself. Because, you know, I'm the dictator. I can do that, right? So they chose a month that everybody likes in the summer, right? They didn't choose February. They chose in the summer. Who was the dictator? Julius Caesar, yeah. Yeah, Julius Caesar. And they loved him so much when he showed up at the Senate to give a speech, they put a knife in his back. Yep, knock that off. Okay, we don't want any dictators. But he had a nephew, and his nephew became the next dictator, and his nephew said, oh gosh, you know, Uncle Julius, you got a month named after him. I want one too, right? So he added a month, and he chose the summer. What was his name? Augustus. Yeah, Augustus. And then, so that was 2 more. Now we're up to 12. And then at that point, the Senate finally grew a backbone and said, knock it off. No more months. We still had dictators. Okay. The Romans still had dictators. A student for a science project had a petition to have dihydrogen monoxide banned, and went to all the parents in the neighborhood and said, did you know that 100% of people exposed to dihydrogen monoxide die? And did you know that dihydrogen monoxide is found in tumors? All tumors have dihydrogen monoxide in them. And did you know you have this in your home? And did you know if you inhale dihydrogen monoxide, you could die? And the parents are like, oh yeah, I'll sign that. That sounds like some nasty stuff, whoa. Right? So then the student goes to the science fair and says, look at all my parents, they're morons. Now, we laugh at this and we go, ha ha, okay, right? We're too smart for that. Now, let me show you something else here. Oh, dihydrogen monoxide is water, in case you're asking, okay? Now, here's one for you, formaldehyde. Formaldehyde is a preservative that is used in vaccines. And it's used like 50 micrograms. No, is that micrograms? Yeah, per dose, okay? Found in a vaccine. And when people heard about this, they're like, what? That's that stuff they stick in the dead cat in biology lab, right? And you want to stick it in my kid? Whoa, no way, we're not doing that. And say, well, okay, all right, but here, just for comparison, a pear bought at Whole Foods Co-op has 7 times more formaldehyde in it. 7 times. And a newborn, if you eat a newborn child, roughly 10 times more formaldehyde in it. So, just because something has a chemically sounding name does not mean it's dangerous. We have to understand a little bit about it, like how much of it is there? What is the exposure, right? How many bowls of Cheerios do you need to eat to reach your LD50? This is what we call science. Now, in your textbook, we have some things where atoms come together and form ions. We call these polyatomic ions. Polyatomic ions. So this is multiple atoms come together and form ions. And there's a whole list of them, and I'll show these to you here in just a moment. And then we have these things called oxoanions. And oxoanions, these have oxygen attached to some element, but different numbers of oxygen. So, let me give you some examples of these things here, maybe. Okay. Okay, so polyatomic ions. I'm going to go polyatomic ions. Okay, polyatomic ions. So polyatomic ions, these are multiple atoms joined together and we have a charge. So for example, we have NH4+. That's ammonium. It's a group of atoms joined together and they have a charge. Okay, that is a polyatomic ion. Now we do have these oxoanions where they are things with oxygen. So for example, we have NO3-. This is nitrate. And then we have NO2-. That's nitride. And then we have N, and that's nitrate, nitride. Oh, did I say that wrong? I think I said that wrong. I'm going to have to reverse that on the video. Okay, nitrate. Let me write that down here. Nitrate. Okay, this one down here is nitride. Nitride, and this becomes nitrite. So they have different endings on there. There's ate, ite, and ide. Okay, I think, and if you're ever studying a language, I think they call these conjugations when you change the ending of the word. Okay, now some more examples here. There's sulfate and there's sulfite. Sulfate is SO4 2-. Sulfite is SO3 2-. Now the nice thing is with these is the charges are the same. So we don't have to remember that the charges change. So that's helpful. And then the one with the most oxygen atoms, the sulfate, has 8, ATE. And there's a student years ago who told me the way that she remembers this is that it ate the oxygen. So it ate more, it's got more oxygen. So ATE means that it has more. And then if that wasn't enough, sometimes there's more than 2 different versions. So 8 and ite isn't enough. So here we have ClO4. And so that's 8, we change the ending to 8, but we put a per in front of it. So it's like more, it ate more. So it's perchlorate, ClO4, chlorate, ClO3, chlorite, less, ClO2, and then hypochlorite, hypo meaning below, hypo, below, ClO. Now we don't use these ones quite so much, but the eights and the ites we do. We do use the eights and the ites. Now in your textbook, there is a table of polyatomic ions, and it looks like this. You should get to know these. Make some flashcards if you need to. These are the common ones. There's more than this. There's a lot more than this, but these are the common ones that you should get to know. All right, so what kind of bond forms between two nitrogen atoms? Covalent, yes, because they are nonmetals. Nicely done. No, it's not James Bond. Okay. What type of bond forms between two magnesium atoms? Metallic bond. Okay, nicely done. Okay, well done, well done. All right. You know, I'm going to expect that now. Is that operant conditioning? I have to ask Professor Bates. So naming compounds. Oh, yeah. This is a lot easier than naming children, let me tell you. I used to teach high school, and when I taught high school, I got to know my students a little better because you spend more time with them and such. And it was a small town. And so I was like the science teacher. So I would teach biology, high school biology for 10th grade, and then anatomy, physiology for 11th grade, and then chemistry for 12th grade. So some students I'd have for 3 years, right? And you're like, man, if you really don't like your teacher, you're stuck with them for 3 years. Anyway, so I really got to know the students. And then when my wife and I were going to have kids, she's like, oh, I'm pregnant, we're going to have kids. And we're like, woohoo, we're going to have kids. And we're like, what do we name them? And she'd throw out names, and I'd be like, oh, no, man, oh, no, because I had this one student, right? And they had the same name. The kid was a total, oh, man, right? And it like ruined so many names. And it was just me, because she's like, well, it's a perfectly good name. It's like, I agree, it is, except every time I look at our kid, I'm going to think of, that jerk from, whenever. So if you ever decide to have children, it's a good idea to not know anybody. It'd make naming a lot easier. Okay. All right. So, hey, folks,